The LS Electric L7C Servo system can be controlled by three types of pulsed inputs. Pulse and direction, where one signal provides the movement pulses and the other provides a direction of rotation. Clockwise counterclockwise, where one signal provides pulses for one direction and the second signal provides pulses for the other direction. And quadrature phasing, where if one pulse train leads the other, the motor rotates in one direction, and when the phasing flips, the motor runs in the other direction. In this video, we'll do the pulse and direction example because it's the most common, and the other two use basically the same configuration and setup. But first, we have to connect our controller, usually a PLC, to the servo. Getting the wiring right is really important, so we're going to spend a few minutes on that. If you're already familiar with wiring, you can skip ahead until the red wiring banner in the upper right corner goes away. You have two options. You can connect via differential pair line drivers. That's easy. Just connect the plus to plus and the minus to minus for both signals. It's the most robust, and it allows the drive to accept signaling up to 1 megabit per second. You can also connect via open collector, like this. The current flows from the 24-volt supply through an internal current limiting resistor, through the LED in the opto isolator, to the open collector transistor, which switches the signal to ground to turn on the opto isolator. I got these wiring diagrams from the L7C Servo Quick Start Guide, which I can't recommend enough. It has everything you need to know to get up and running quickly. You can download that from the drive's page at AutomationDirect.com. This is for a 24-volt system like a PLC. What if you have a 12-volt or a 5-volt system? Well, no problem. Instead of connecting this guy, the L7C Servo drive gives you direct access to the opto isolator LEDs. Just connect these through an appropriate current limiting resistor and you're good to go. These are the recommended resistor values. You can even wire it this way for 24 volts by supplying your own 1.5 k ohm resistors instead of using the built-in ones here. We'll be using the internal resistors via the PCOM signal in this demo because it's so much easier. This open collector signaling can handle up to 200,000 pulses per second, and you'll want to keep the wires to less than around 10 meters. The differential signaling can typically be used out to around 30 meters. That depends on your signaling rate and system configuration, of course, so consider these rough estimates. In all cases, please do yourself a favor and use a good low capacitance data cable with a shield. And connect that shield to the drive's frame ground only. Don't connect the other end of the shield. Why? Because when you connect the other end of the shield, you create a closed circuit that current can flow through. So when outside electromagnetic interference hits the shield, it creates currents in the shield. And that creates fields inside the shield that can couple currents into your signal wires, which can actually cause more problems than no shield at all. By only connecting the shield at one end, you break that path so current can't flow and create disruptive fields inside the shield. And that applies to both kinds of wiring. There is one thing you need to be aware of with the L7C Servo system. If you use the optional terminal block to access the drive's I/Os, while the 50-pin cable is shielded, it doesn't give you a chassis ground connection at the terminal block, which means the shielding stops here. So how do you shield these wires if you can't extend the drive's chassis ground from the terminal block? Easy. Just connect their shield to the PLC's chassis ground. But make sure you don't connect the shields here, otherwise you'll get that current path again and all of the issues that come along with it. Of course, Automation Direct has really good, cost-effective cables for these kinds of applications. Here are some suggestions to get you pointed in the right direction. I have our demo set up as an open collector from a Bricks PLC, and I would recommend using this part number or something like it for the cable. I am using the handy terminal block you can get for the L7C Servo, so my shields are connected like this. If you're using differential pair, I'd recommend a cable like one of these for a good low capacitance, high data rate cable. The only real difference is the color coding of the wires, and this one, which is foam polypropylene. It has the lowest capacitance, so it won't round off your signals as much at high data rates. Now, at the lower bit rates we're using, that really isn't a factor. And remember, at Automation Direct, you can order any length cable you need, and there are no cut charges or shipping on orders over $49. Now, I hate spending so much time on wiring, but if you don't get that right, you're setting yourself up for all kinds of frustration. Okay, that was the hard part. Once you have the wiring complete, setting up for pulse signaling is easy. I'm going to go to the Setup menu and return to factory setting so you know exactly where I'm starting from. Of course, we always power cycle the drive or just reset the drive's controller after a factory reset to make sure everything is totally cleared out and we get a good clean start. Go to the setup wizard. Now I'm only going to cover the stuff significant to pulsed input here and breeze through the rest. If you need to see how to set up the other stuff, then check out the quick start videos where we walk you through all of that. Let's go online and read the current drive configuration, which should be the default since we just did a factory reset. The encoder setup is fine. We want pulsed input, which is the default. Here are the three choices: AB quadrature, clockwise counterclockwise, and pulse and direction. You can also specify inverted versions of those if your signaling happens to be upside down. We'll be using pulse and direction for this demo. You can also filter the incoming pulses. We're using Open Collector in this example, which has a max pulse rate of 200,000 pulses per second. So this cutoff is way above that. We could probably even lower that some if we wanted to. We don't really need to worry about filtering noise for this demo, so I'll leave that alone. And rotation direction doesn't matter for this demo. I'm going to change the electronic gearing, so instead of using the native pulses per revolution, the system will use 100,000 pulses per revolution, just to keep things simple in our demo. And this stuff is all fine for our example. Digital inputs. All we really need for this demo is a servo enable and the inhibit signal, which I'll put on input 3 because I have something wired to input 2 for other videos. And I'll disable the rest. We're not going to use any outputs in this demo, so I'll disable those. And we're not using homing. Write all of that to the drive. Wait for confirmation, and we're good to go. And again, we always reset the controller or do a power cycle after making changes to ensure everything gets cleared out and we get a good clean start. I'm using a Bricks PLC to generate the pulses simply because that's what I had laying around and it's super easy to set up for motion. Here's the wiring diagram I'm using for our Open Collector example. If I wanted to do differential pair, I would need to add this Bricks I/O module. There's other videos showing you how to set up the Bricks PLC for motion, so we're not going to spend time on that here. I have the Bricks PLC set up so that on the first scan, the axis gets configured, and whenever C0 is toggled, the Bricks PLC will send 100,000 pulses to the servo, which, since we set the servo to 100,000 pulses per revolution, should give us one complete revolution. I love that I can do all of my motion with just one instruction in the Bricks PLC. Well, the PLC is online and running, so in the servo's DriveCM software, I'll go to the digital inputs and enable the servo. Back in the Do More Designer software, I'll toggle C0. And yep, the servo motor rotated one full rotation, exactly what we expected. If I enable the inhibit and then toggle C0 to send the pulses, nothing. The inhibit signal prevents the pulses from getting to the drive's controller, but it doesn't release the holding torque from the motor. Only the servo output enable can do that. Release the inhibit, toggle C0, and we're back up and running. Well, that's all there is to it. The DriveCM software makes configuring the L7C Servo for pulsed input super easy. Just make sure you pay attention to the wiring and you'll be up and running in no time. What if you need encoder feedback at your PLC for position verification or to trigger some other action? Easy. Back in the Setup Wizard, on this page, you set the number of pulses the drive will output per revolution. You'll usually set that to the same thing as your electronic gearing, and you can set up the format of the encoder output signals. You then connect the dedicated encoder output pins on the drive back to your controller. Program your controller accordingly, and you're done. Well, that should be enough to get you started with using pulsed inputs on the LS Electric servo systems. Click here to learn more about the LS Electric servos. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to this YouTube channel and click that little bell icon so you'll be notified when we publish more videos like this one.